I'm going to talk about classes and abstraction. In this lecture, you will learn about classes, member access specifiers, public and private, how classes are implemented. You are also going to learn about setters and getters. You are going to learn about what are constructors and what are destructors. I'm going to finish off with the concept of abstraction, which then is going to unravel what is an abstract data type and how do we implement abstract data types using classes. You recall that in our previous lecture, we represented an object, time, and out of that, we were able to create a class, and we called that class clock. We then looked at the behavior of member functions or members that are under public. We also looked at member variables that were under the member access specifier private and how do they behave. We had member functions here, and also we looked at member variables, and we say that member variables can also be called data, and member functions are also known as operations. Let's say that when you have a class like this, it becomes a new data type. As a consequence, you can then create an object. As you can see here, we have clock, which is a data type. My clock is an identifier. And here, this is a declaration statement that is creating an object which can be visualized as a memory space that has fields in it. In our instance, we have my clock, the object, with 3 fields in it, that is hour, minute, and second. You can then see that in the clock, we did not provide the code for set time, this function. What we have here is just a prototype. The code was then written outside class clock. This was for the reason that we did not want to crowd or clutter class clock. This code for set time was written outside the class. We could have written it inside the class, but doing that will then make class clock become bloated. But that is not only the reason why the class was written outside. It was also written outside because we wanted to separate the class from the implementation. This is going to become apparent when I start to talk about the concept of abstraction. And also, I want to point out the fact that in your assignment, you were instructed to split your code into 3 files. Already, you were implementing in that assignment the concept of information hiding. So, I will hold off this discussion of why we are separating here until I start to talk about the concept of abstraction. Now that we have our set time. We now have our main program. And in the main program, I talked about the object. That's where we create our object here. The question now becomes, how do these pieces of code interact? Now, I have this statement, clock my clock. What it does, it then creates this object. And then this is followed by my clock.setTime. And then there are values here, 5, 4, and 30. Those values, what then happens is they are going to be passed to this function setTime. When they get there, what is going to happen is, for example, 5 is going to be checked. See whether is it between 0 and 24. And in this instance, you can actually see that it is between 0 and 24. So it is going to be copied into that action puts 5 into this object. And then next, minute is going to be checked also. And what is in minute? What is in minute is 4. So 4 is going to be checked whether it is between 0 and 60. And in this instance, you can see that it is actually between 0 and 60. What then happens is that 4 is then copied into the object here. This action here, where we are taking what is in M and putting it into min, it is this action that is copying 4 into the object. Then next, what is going to be checked also, it is 30. It is going to be checked whether it is between 0 and 60. And in this case, you can see that it is. So what happens is, what is in S, which is 30, is now going to be copied into sec. That action, what it does, it then copies 30 into the object. The point here is that for us to be able to put the data into the object, we created the object in the main program, but main program does not put the data into the object. We had to call setTime to then put the data in the object. And the path that we took was, from the function call, we had to go to setTime. And then from setTime, we had to go to the object. This is the transaction that is happening between these two pieces of code. We have set our object to some values. In hour we have 5, in minute we have 4, in sec we have 30. We now want to print, we want now to display what is in our object. You can see here that we have a prototype, void print time. And this function, its definition is up here. This is the definition of the function. So in our main program, we do have a function called myClock.printtime. What that does, it takes us to the definition of print time. What then print time does, it is going to actually read what is in the object. It will read the minute. It will also read the hour. When it has done that, it is going to display, you see the see out statement here. That then makes it possible for us to see what's in the object. You see, this definition, if you look at the prototype here, there is a word here this word is important. There is a word that is const. What it means that this function does not modify. All it is going to do, it is going to read from this object. So again, you see, what is happening here is that the main program is not here doing the printing. What it is doing is it is calling a function, print time, and then print time is the one that goes into this object, and then it is the one that is doing the displaying. At times, we would want to get our data from the user. So we prompt here the user to enter the hour, the minute, and the seconds. And then what we are going to do, you see here H and M and S, these are variables that are local in our main function. We then supply those to setTime, and then what setTime would do is going to then pass them to its definition here. And once again, the definition, what it is going to do, it is going to check here, it is going to check the hour, and then in this instance, say that you have typed in 5, 23, and 59. You will see that what it is going to do again, it is going to check 5, and then it is going to put it into our clock, and then it is going to check 23, and then it is going to see that 23 is between 0 and 60, and then it is going to copy it into our object. Then lastly, it is going to check 59, and then it is going to copy that also into our object. So this data is from the user, and then we supply it to setTime. Then setTime passes it its definition, and then this function, what it does, setTime, it is then going to copy that data into the object. There is what is called a get function, and here we have getTime. And you can see that it has reference parameters here. And it also has that const. Now, the assumption here is that we have already used setTime, and setTime has actually set our clock to 5, 23, and 59. And you can then see that in this code, we do have this call where we say myClock.getTime. What does this do? This then, it is going to take us to the definition of the getTime function. When we get there, you will see that in the parameter list, what we have int address operator H, int address operator M, int address operator S. This means that what we are supplying here, what we are passing from the main program, are the addresses of H, M, and S. So we also have the word here, const, which then also signifies that this get function, what it is going to do is to only get. It is not going to change anything. But let us look at its code and see how it is doing this. You will see that what it is doing is it is going to hour. Where is that hour? You will then see that hour, it is in our object. And then it is going to copy 5 and put it into H. So it means then that this H, what has happened here, now in H, what we have 5. That is the path that has been taken there. You can also see here with main that it will then go into my clock, and then it's going to get 3. And then what it is going to do is it is going to put that 23 into M. After that, it is going to go to the object again, and then it is going to retrieve. It is going to get what it does, it retrieves. And then it is going to copy 59 and put it into S. What that means is it is now taking that value and then it is putting it in S. But where it is, if you follow the arrows, you will see that the get function, what it does, it retrieves the values from our object, then it puts them into the main program. Now, this cout statement where we are saying cout H, M, and S, what it is going to do is it is going to print what is in H. And in this instance, what is in H is 5. What is in M is 23. What is in S is 59. And that is going to be displayed here. So you see, the purpose of the get function is to retrieve from the object, is to retrieve the values. But it is not allowed to modify. That's why you see here we have again the word const. This is for security purposes. Make sure that this function, what it does, it retrieves. And then this cout statement, what it is going to do, it is then going to display for us 5, 23, and 59. Again, you do see the fact that the main program, what it is doing, it is using these functions. And these functions are the ones that are allowed to go into the object. So getTime goes to the object, it retrieves, and then it brings the data into the main program, and the main program displays. We have setTime on one side, and we have getTime on the other. What we want to observe here is what these two functions do to the object, my clock. We have the function call setTime, and then what it does, values, as I've said before, 5, 23, and 59 are passed to this very function. This function then, in turn, what it does, it copies hour into the object, it copies minute into the object, it copies second into the object. This object, before there was a value here, but we changed it to 5. Before, in the field of min, there was a value there, and then we had to change it to 23. And the same thing applies also to set. We had to put 59. What has happened here is that setTime has changed the values in our object, my clock. As a result, a set function, or a function that changes the values in the object, it is called a setter function or a mutator function. It modifies the values inside the object. On the other hand, we have the getTime function, and this, of course, it will go to the getTime definition. When we get here, the getTime, what it does, this function is, it is going to retrieve data from the object. It is going to retrieve 23. It is also going to retrieve 59. Then after that, it is going to, where do we put it? It is going to put it into the main program. as I said before. And then it goes into the main program. You also have to realize that with the get function, there is this keyword, const. What has happened here with the get function? The get function, its purpose is to get, is to retrieve from the object. That's all it does. It retrieves values from the object. It does not modify. All it does, it accesses the object. And for us to guarantee that get time gets, to guarantee that get time retrieves from the object, we put the word const. It then means that it is not going to modify. All it is going to do, it is going to retrieve. As a result, it is called a getter function. Its behavior, the get time, as you can see here, it behaves in the same way also as the print time. So, a print time function, it is also a getter function or an accessor function. So, functions that retrieve or only read from the object are called accessor functions. While on the other hand, functions that modify the values in the object or modify the object are called setters. If you have realized, you'll see that every time we would call set time first, then we would then call print time. Set time was called first, and then we would call the get time. Now, in this scenario, what happens if we forget to first set our time? What is going to happen is that if you go to print time is going to take us to the definition here. And then what it is going to do, it is going to, of course, read what is in the object here. So it is going to read hour, it is going to read minute, it is going to read also second. But what is it reading? And what is it displaying? This object, when it was allocated to my clock, the memory space, when it was given to my clock, when it was reserved for use in our program, it was being used by other processes. And we don't know what those previous processes have left in these memory spaces. So what is in these memory spaces are garbage values. These are strange numbers. So what is being displayed here by print time, the output is garbage, strange numbers. The same thing with get time. You would say that we'll set the object first and then we'll call get time. In this instance, let us see what happens. Get time will take us to its definition, and then get time, what it is going to do, it is also going to read hour, it is also going to read minute, it is also going to read second. When it does that, these values are going to be retrieved to the main program. That's where they are going. They are going to the main program. So whatever was in hour, minute, and second is now being retrieved from the object, and it is now in the main program. So we then see here that we have the cout statement. This cout statement, what is it printing? It is printing whatever get function has retrieved from the object. And in this instance, the get function has retrieved garbage values. So what is displayed here are garbage values. They are strange numbers. So what do we do? What is the solution? In the previous slide, we had a problem that whenever we would call print time without first calling set time, what we will have displayed was garbage values. The issue was because our object was not initialized. And in order to solve that problem, we are going to use what is called a constructor. And this constructor, what it does, it is going to guarantee that our member variables are going to be initialized. We have two types of constructors. We have constructors with parameters, and we also have constructors without parameters. And at times, that constructor without parameters, it is also called a default constructor. But how do I know that these are constructors? They've got some characteristics. You realize that a constructor is the same name as that of the class. If you come here, I have clock, and the name of the class is also clock. You will also see that they don't have a type. If you look here, you'll see that there is no return type here. Constructors, they do not return any value. A class can have more than one constructors. But what must be made sure of is that they have different formal parameter list. As you can see here, we have in this constructor with parameters, it has 3 parameters. And then we have this constructor without parameters. In the brackets are empty. What we have to know about constructors is that these constructors, they are executed automatically, but then it depends on the type of values that you supply to it. Let us see how we use the constructor with parameters and the constructor without parameters. And here, let us start with the constructor without parameters, and we call it a default constructor. There is this statement. We have seen it a lot. My clock, this is a declaration statement. What it does, it then creates an object, my clock. This then invokes the default constructor. And then what happens here is that the default constructor is going to run, and it is going to set hour, minute, and second to 0. Now we have starting values. Our object is now properly initialized. It now has proper starting values. On the other hand, we have the constructor with parameters. The constructor with parameters, what it does is the moment we supply 5, 12, and 44, those are passed to the constructor with parameters. What it does then, it is going to check, for example, 5, is it between 0 and 24? And if that's true, it is going to copy that value into the object. It is going to also check the minutes, and then it is going to copy that value into the object. And lastly, it is also going to check the seconds, and then it is going to copy that value into the object. Now, what if we didn't supply here 5? Instead, we got something that is outside the range. Let's say that here, H, the value 40, what will happen? It means then that it is not within this range. So, what will then happen is that this second option of our if else will then execute, and then it will put 0 in hour. If the value in minute was not within this range, say that you have typed in 70, what it will do is the first option will not execute. The second one is the one that will execute, and then it will put 0 in minute. The same thing will also happen for seconds. Now you see, we now have a way of making sure, of guaranteeing that our object has proper starting values. So it is always advisable for your class to have a default constructor so that all the time when you are creating your objects, they do have proper starting values. The code for the constructor with parameters is the same as the code for setTime. So in a way, it doesn't make sense for us to then duplicate this code. We can solve this very duplication by calling setTime inside the constructor with parameters. Let us look at another type of a constructor. It is called a constructor with default parameters. This constructor, it has default values. The issue is, what is a default value? This is a pre-established value or a preset value. In this instance, normally we use 0. This value is used when you do not supply a value. Whenever you do not supply or you forgot, then that pre-established value, it is then used in place of that which you didn't put. Now, how does a default constructor with default parameters look like? It looks like this, where we have in the parameter list, each parameter here is actually set to 0. We are giving each parameter a default value of 0. And this can replace both of these constructors. Now, the code for this constructor with the default parameters is the same as that of the constructor with parameters. The main point here is, how does it work? Let's say that I have declared an object here, my clock 1, and I have done nothing in terms of supplying values. What it will do is it is going to put those values, and these values are our default values. Let's say that in my clock 2, I only put 5. What is it going to do? It is going to put 5, and then the other values that I did not supply are going to be set to 0 and 0. The same applies to my clock 3. I supplied here hour and minute, but I didn't supply seconds. And then seconds is going to be set to a default value. And lastly, if I then supply everything, then it is going to actually also set that particular object to 7, 40, and 80. There is another special kind of a member function, and this is called a destructor. It is the opposite of the constructor. What does it do? What is a destructor? Now, the properties of a destructor are, it doesn't have a type. Like a constructor, it does not have a type. It does not have parameters. It also has the same name as the class. If you look here, you'll see that it is called clock and it is called clock. But how do I know that it is a distractor? It is because it is a character here, the character. It is preceded by this character. And this signifies that this is a distractor. What does a distractor do? We are now getting here into the concept of resource management. The distractor, what it does, it distracts, it destroys, it deletes an object. Remember, an object occupies space. So when we are done with the object, it makes sense that we have to give it back to the operating system so that other processes use that memory space. In other words, sharing is caring. So when I'm done with the object, I have to give it back. So your class must have a distractor so that when the object goes out of scope here, what does it mean? It then automatically executes. The moment the object goes out of scope, it then distracts or destroys that object. But what does it mean to say that the object is now out of scope? It means one of these things. Otherwise, the function has ended, or the program has ended, or the block has ended, or you have called the delete operator. So this distractor, what it does, it executes automatically. And its main purpose is to release back the space that was occupied by this very object to the operating system so that it can be used by other processes. In real life, we are concerned about using items, not how items work. That is their design. We are not concerned about that. When I'm using a cell phone, for example, I'm not concerned about how it works. I'm concerned about being able to use that cell phone. The same thing goes for a remote. All I want is being able to use that remote, not how that remote works. So, this concept where we are separating use from design, we also see it, when it comes to cars. Driving a car, we know how to use a car. But we do not worry ourselves about how the car engine works. Again, you see this concept of separating the design from use. This is what is called abstraction. What it does is it focuses on what an item does, item use, not on how the item works, that is the design. So this concept of abstraction can also be applied in our scenario. It can be applied to data. When it comes to data abstraction, it is a process of separating logical properties of data from its implementation. What does that mean? Because when I started, I said that I'm going to make the point of having the implementation of a function outside the class more clear when I start to talk about the concept of abstraction. The concept of abstraction allows us to separate the design from use. Now see, when we defined the class clock, it had member functions, print time, get time, set time. Those and member variables, hour, minute, second. That definition, those are logical properties. But you then see that when it comes to creating and storing objects, and performing the operations on the object, where we were now setting the time, when we were now printing, retrieving values from the object clock. Those details are the implementation details. That's where the concept of abstraction comes in, and it is an important concept. It allows us, you will then see later, that it then allows us to separate the class, that is the definition, that we call the specification, from the implementation. And this is good in what? In that next step, it is when we are now implementing the concept of information hiding. We'll then split our file into three. You see that we have a specification, that is the class, those are the logical properties. And then we'll have the implementation, that will be our member functions, the definition of our member functions. And then we'll have the user program. So you see, the concept of abstraction is important, where we have to separate use from design, so that the client program, that is the user, knows how to use setTime, not how setTime works. What is an abstract data type? An abstract data type implements abstraction. In other words, it separates logical properties from implementation details. The properties of an ADT or abstract data type are the name, which is also called the type name. An abstract data type has got a set of values that is also called domain, and then it has a set of operations on that data. Let us look at an example, and we have been busy with this example, that is clock. You will see that clock ADT has a name, clock, and then it has domain, that is hours, minutes, and seconds, to represent the time of the day. But also, that example that we have been busy with, you would see that it had operations or functions: set, print. Now, to implement an ADT, what we'll then do is you will represent the data, and then you will write the algorithm to perform the operations that we have done. That's what we have been busy with in this lecture. If you look at the example that we have been busy with, that is clock, you will see that the definition of class clock had only the specification of the operations. There were prototypes, just the headings. That's what was in the definition. But the functions, that is the implementation, was done separately. So you then realize that what were we using here? We were using the concept of a class. So classes are actually a way of implementing abstract data types. C++ classes are actually built to handle abstract data types. What did you learn? In this lecture, you learned about classes. We had an example, class clock. You also learned about member access specifiers, public and private. You also explored how classes are implemented. On top of that, we had to talk about setters. These are functions that modify the object. For example, set function. We also talked about getters. These are functions that retrieve, they read from the object, but they do not modify or change the values in the object. They only access, like get function, print time. We then talked about constructors, constructors with parameters, constructors without parameters, constructors with the default parameters. The reason was that the object was not properly initialized. If we do not set it, Then we go ahead and we'll print garbage values. So to avoid that and guarantee that our object is with proper starting values, we had to use constructors. But what happens when the object is out of scope? When you are done with the object, the memory that it is holding needs to be released back to the operating system. And in that instance, we had to use a destructor. What it does, it destroys the object. It releases back that memory space to the operating system so that other processes will use that space. We then finished off by talking about the concept of abstraction. It led to the concept of abstract data types. Then we had to learn that clock is actually an abstract data type. As a consequence, classes are used to implement abstract data types. The end.